GrrCON Day 2? Exciting? No. This is my buddy Tom Richards, and he's going to talk about some stuff, some software security in the real world. So give it up for Tom.
Thank you. So good morning, everyone. Thanks for coming bright and early to my talk. I really appreciate it. This is like one of the best crowds I've ever had here. Which could go either way. Well, it's day 2 at the con, right? 10 o'clock. If anyone went out, they're still sleeping. And, you know, Chris spoke yesterday, so that's what everyone probably came for, right? Did he have a good keynote? I didn't show up until yesterday night, so I missed it, unfortunately. But thanks for coming out to my talk. I really appreciate it. Quick run of the crowd. Who here is a consumer of security services? Have pen testers come in, have to go through reports and figure out that. Who here is a practitioner in the security field, actually doing the pen testing and all that fun stuff? Great. No, pretty good mix. Perfect. That's what I was hoping for in this talk. I've been giving this talk to students for the past 2 years, so this is my first talk in front of actual people. So we'll see how this goes, all right? Again, my name is Tom Richards. I am a senior security consultant with Citadel. We are a software security firm based throughout the U.S. and internationally. That's my Twitter account. If you want to follow me, that's cool. Sometimes I tweet, sometimes I don't. I presented previously before. I think this is my 3rd or 4th year here. Probably the 3rd speaking time here. It's great. I love this conference. I'm so glad to be back. I have also presented at CarolinaCon, DerbyCon, and also B-Sides San Francisco in various topics. I'm an organizer for B-Sides Rock. Yeah, B-Sides, right? Great conferences. If you have a B-Sides locally to you, definitely go to it. They are fantastic. And I'm also a member of our local 2600 group. This talk, hopefully you read my description. I'm going to talk about some of the things that I've run into in the field and what it means to do software security in a consulting thing. And I'm also going to give you guys some pointers of when you're looking at vendors and sort of the other side of the table, right, when you're going through this life cycle. So the projects I've worked on in my 3 years at Citadel have been staff augmentation at a large financial firm, where I was helping them. In 2013, they finally realized that they wanted to do mobile. So we were helping them securely develop their mobile banking application, also their employee initiatives for BYOD. They were a large firm, traditionally BlackBerry. Does anyone have to manage mobile devices out there and have everyone go, I want my Apple, I want my Android to get email? Yep. So that's what they were facing, people coming in with those requests, and they had some very important information on there. So I'll talk about that a bit later. Mobile pen testing, traditional mobile assessments, web app assessments, network assessments, you know, traditional pen testing sort of things that I've been going through. I also do quite a bit of red teaming. Actually, I'm leaving Sunday to go break into a building in LA. So yes, it's a lot of fun. I get to do a lot of fun stuff here. And now with my more senior position, I do scoping calls and helping out with the clients. So if you're on the consumable side of security, when you get on the phone with a vendor and go, hey, here's what we want, I'm usually the person on the other end of the phone going, okay, here's what we have. Not sales. I'm after sales. Like once it goes through the sales process, we figure out how much we're going to charge you for this. That's when it gets to me. So making sure we understand your need, and also make sure our services are going to meet your expectations. So I'm doing that side of the house now too, and that's some pretty interesting stuff to talk to clients about that. I've always viewed security as the second level in industry, right? Coding's hard, right? Writing software is difficult. Computers are hard. Designing things is hard. And security is really hard. Right? When you're going through this stuff as a consultant, I need to know as much or more than your developers. I need to know as much or more, even of your own system, than your system architects, system engineers, and support staff. Because when I'm finding issues that relate to the security side of your business, I need to be able to explain those in confident and knowledgeable terms so that you understand us. right? You're not going to have a vendor that is going to sit there and go, oh, blah, 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 that's an issue because we say it's an issue, right? You have to have facts. You have to defend why it's an issue. So we need to understand that. So well, I even tell kids, I know college students looking to get into security, I tell them do 1 or 2 years, maybe, about 1 or 2 years in industry, in whatever you are doing. Be it network support, system support, or developing. Because if you want to go straight into security, you're going to have a huge curve you're going to have to get over just to, one, understand how companies work. I've had people work with me who had never worked in an office before, and we had to go on a client site. So things we might take for granted, like office etiquette and just interacting with people in an office, where the break room is and what's typically in a break room, these kids had no idea. So I strongly encourage, if anyone is anyone a college student? Okay, one person. So one person's going to have benefit out of this. Be in industry for a little bit if you're going into security before you do it, right? It helps everyone out in the long run. I have a really crappy note there. This is from Eric Bees. He's the CISO. That's somewhere. I forget where he is. This is from one of his tweets, and it really brings to the front what software security is. And what we're talking about by software security, the network layer is taken care of, right? We got that padlock in the corner. We're good, right? It's SSL. We're fine. But this is where the software security turns in. If you put a negative number in your quantity, now the shopping cart owes you money, right? This is the perfect example of what software security is. The network layer is taken care of. We got our secure communications, but the app is broken. Like I was saying, I was at the bank, a large financial investment firm, helping them design their mobile application. And that was really interesting because you had to explain to this bank what a secure mobile application looks like. What does that mean? What, both Android and iOS, because that's the two popular ones, what would that be? What things are we concerned about, both on the client side, which you can't trust a client at all, and also on the back end. And that's where all the juicy stuff was. And that's what the line is here with the devs. They thought that, oh, it's mobile. Only the mobile phone is going to talk to our back end web services. I'm like, no, dude. Like, you put a published web service out there on the internet, anything is going to talk to it. Right? You have a RESTful service, fantastic, but you need to secure that system. And that's what feeds into my next line, was mobile pushing security back to the 90s. It's gotten better more lately. But when mobile was first coming out in 2010, 2011, people were pushing these apps. That's when Android and iOS were really taking off. Developers were forgetting all the web security stuff that they had been doing for the past 20 years. And we were finding simple, dumb things that they were building into their back-end systems, assuming that the only thing talking to their back-end was going to be the mobile device. That you still can't hit it from a web browser or through burp or anything. So we told them they had to fix that, right? Because you can't trust anything from the client. You have to validate what comes in. And we built a pretty robust system for them to use. BYOD. This is one of the worst ideas anyone's ever had, quite honestly. I don't know if any of you guys have to deal with BYOD, but it is just a pain. Yeah. Ugh. So, this investment firm deals with very sensitive information. They deal with mergers, IPOs, not just mergers, but people acquiring other companies and stocks that are coming out. So very critical information they have going on there, and their staff are requesting to use iOS and Android. Now, for business purposes, and we're dealing with really sensitive information where an email on someone's device could literally either make someone a couple $1 million or lose someone millions of dollars. So, poking the bear, are iOS and Android as secure as BlackBerry when looking at that sort of data? It is actually a question. Any comments? Either way, pro or con? Pro or con? In my opinion, it's not. There's no way. The security controls that are available in iOS and Android are years behind what BlackBerry could do when it comes to securing data on the device, securing communication between the device and the backend server, and just the attack surface of the platform. There is no root exploit for BlackBerry. Now, they're coming out with an Android phone in a couple months. It was just announced, so that's going to change things, and that's going to be interesting. But the BlackBerry OS, there is no root exploit. There is no root. You cannot get root access. You can get root on iOS and Android every time they release a version, right? You can do it. iOS and Android are consumer devices adapted to the business world. Samsung has done quite a bit with Knox and Safe to produce some BlackBerry-like APIs available for businesses to start to manage, but not every MDM vendor supports everything that Safe puts out there, that Samsung puts out there. So in my opinion, no, and they had classification levels for what was sensitive data and what was not. And if your email was too sensitive, you were not getting iOS because they could not properly secure it in a way they would secure BlackBerry. And the government looks at the same thing too, right? The government still primarily uses BlackBerry when you start to get into the fun stuff, right? Obama's not walking around with an Android. He has a BlackBerry. So that's my 2 cents. I'm welcoming anyone to talk about that after the talk. Moving on to mobile app pen testing. Sometimes, apps are pretty good. Other times they're just complete garbage. This example is for a fast food vendor of beverages. I see some cups from them in the room, so we'll leave them nameless. They split their code per region. So they started doing their mobile development here in the States. And then for each localized region, basically each language, Europe was its own app or whatever, they forked the code for them to be able to develop services and features natively. This one, I had to stop after 2 hours of testing because literally just looking at the application, I had to stop. I had 29 findings. It's just ridiculous. That's an incredibly high number of findings within only a few hours of testing. Like literally, I didn't poke or do anything. It was stuff on disk, stuff going in the log file, passwords being spit to the log file in plain text. And if everyone knows on Android, any other app can actually request the log file to read. So that's just asking for trouble, right? And SSL issues. Oh man, everyone sucks at doing SSL. TLS, I should say, right? SSL's dead. We can't say SSL anymore. It's all TLS. Every assessment, we find SSL issues. I did find Heartbleed once after it was published, which was pretty cool. I was doing a red team engagement against a law firm, and their McAfee, externally exposed McAfee server was vulnerable to Heartbleed. So we were not only able to pull down the private key of the server, which you can, there's tools out there to do that with Heartbleed. We were able to pull down their corporate AV policy. We knew what apps they were excluding from being scanned, and we knew what directories they were also excluding from being scanned. So we were able to directly target our attacks to basically go after Office because the AV was not scanning Office. So the first two we don't find as much anymore. Poodle, we're still finding SSL version 3. I mean, it was depreciated 15 years ago. Turn it off, right? Invalid certs, that's a pretty big one. People who have stuff that's already expired out there or self-signed out there. And weak ciphers supported. That happens quite a bit. Low bit strength cipher suites. It's like, come on. We can fix these things very easy. You just upgrade the software, right? Web app testing, it's run of the mill when we get out there. We're still finding things that we found since the 90s and early 2000s, still injection flaws. We do find authentication authorization issues here or there. There's maybe a couple things on the top 10 specific vulns that I haven't found through the course of testing, but it's just, here, other people have here and there, right? Larger companies have their act together. You know, the banks, the large ISVs, they really have their act together when it comes to this. So when we do QA testing, sometimes we don't find a lot of interesting things. Sometimes we do. Just one development group just isn't doing stuff up to the corporate security policy, right? Because these companies will have development standards for the developers to use. They have guidelines on what to do and what not to do to make sure their code isn't totally broken. So, you know, when we find stuff, when it gets to us, injection code level issues, it's someone's missing something. Smaller companies, it's hit or miss. You know, we had a client come to us because their client said that they had software security issues, so they needed to get pen tested, and they recommended us. So we went through and did it, and an app was just thoroughly broken. You know, full SQL injection. I dumped the whole user database. It's one of those things where it's so broken, you're trying to figure out if you're going to have enough time to finish the report. Hit a button. Did something happen? No. Okay. You know, those are where we're still finding fun things, right? Where it's exciting, have a lot of highs, and, you know, you feel good about yourself going through the report. Like, yeah, we broke this app. Smaller firms definitely need, like, more help. They don't have the structure that the larger firms have to even have coding standards or really know what a secure code looks like when they're going through. I'm a client of this bank. Is anyone a client of this bank? Does anyone recognize this? No? No, you do? Okay. So I was given a username, right? And then also a token to sign in, a two-factor token, right? And that's the primary method of signing in through the bank, is using your username and this two-factor token, which is PIN and a randomly generated number, right? So it's fantastic. But you also have a password, because there could be instances where you're not able to sign in with your token. Certain functions of the app were disabled when you did password auth because they weren't able to really prove it's you, right? Because you don't have the token, it's just a password. Could be anyone. I guess the token's kind of the same way, but then this pops up when you ask for your password, right? So they didn't ask for me to just put my password in. They asked for the first, the sixth, and second to last password. What does that indicate? It's encrypted. Yes, they're not hashed. Well, or plain text, right? Told them it was plain text. They were like, no, it's actually reversible encrypt. There's a backend service. I'm like, that's awful. So they were storing the passwords in reversible encryption. And this is another large bank doing this. Yeah. Well, it also changes each time. So it doesn't ask for the first, sixth, and second to last. It could be like the second, fifth, and like the seventh or whatever last. Yeah, because you're sitting there going, what the hell is the first one? You're right, because you pull up Notepad or pull up the sticky pad, you write down your password and go, oh, okay, first, yep, oh, that's good. Yeah, this is, come on. We said they were storing it in reversible encryption and only their backend service can talk to it. So that's a positive, right? Doing architecture works is pretty interesting too. We had do something for some mobile apps to design their system. And when it came to guidance for a secure client side, right, that's pretty common. Android, Google publishes stuff, Apple publishes stuff. That's pretty well documented how to write a secure Android or iOS application. Things to avoid, things to include, not do when you're going through the code. It's the back end that no one has a template for to figure out if that is secure or not. And what does that mean to make sure your back end is secure? Validation, authorization, all those issues are going to pop up in the secure design. For this one, yep. So for this one, we reviewed, they did have the APIs developed. It was a RESTful API. And this client is a rewards application for fuel. Okay, so you're buying gas. So as you buy gas, it gives you reward points to use at other retailers or at other fuel stations to save a couple cents off your pump, right? I was on the phone with this client before they get in, and the security group that brought us in was not, the developers, right? So we got on the phone with the developers and the developer lead, and this lady just says straight out to us, "I only care about PCI." Like, okay, but there's, other things to worry about here other than just PCI. There's, these kinds of issues, and this is stuff that we're testing for. And then we're going through the conversation, and she was like, well, wait. Is that a PCI issue, or is that a normal security issue? And I was like, it's, that's normal security. You gotta make sure. She's like, I don't care. The only thing this lady was concerned about with the developers is to make sure that your credit card number was not stored in plain text or used in plain text transmission. That was her only concern. Everything else be damned. Dump everyone's information, screw authorization, just have a whole bunch of fun. As long as that credit card number isn't exposed, we're good. Which, that's kind of silly. When you looking back at the breaches that have been happened with the healthcare companies, and I get that email from Anthem, and they go, we got breached, yep. All this information got stolen. Yep. But the good news is that your credit card number wasn't compromised because we stored that on a different server. It's like, well, fantastic. The one thing I can change overnight was the thing that wasn't stolen, right? So now my, 4-year-old, 6-year-old, 3-year-old, and 1-year-old kid has their credit card, their social security number stolen, which is fantastic. And thank you for the free 1 year of credit monitoring for my 1-year-old kid. That's really going to help them when they're 18, and the people who now have all their information start opening up credit cards in their accounts, right? Fantastic. Thank you, Anthem. And Rand. So, authentication, they did have, this is back to that rewards application. They did request, they did have some OAuth-like thing here. They told us it wasn't true OAuth, and we were like, well, how random is it? And they were like, it's random. And we said, oh, okay, make sure that's random. Username and password, right? And the post request. So there was, this is the body. Yep. So you would have the body. So they weren't putting get queries, get strings in, which is good. You got back this information. Account number was actually sequential across the entire system. This member ID was interesting because that's what the user would actually use instead of their account number. Their account number was just how they kept track of you on the back end. The member ID was how you would authenticate at the pump if you didn't have your card to get your rewards. And the fun thing is that the member ID was your phone number plus 3 other digits. So that's always a plus, right? Guessable, a thing to just type it in the pump to be able to get rewards. But okay, that was their system. We said that was bad. And then you would get back this access token. So separate from the header access token, which grants you access to talk to the APIs, the access token was supposed to be unique and cryptographically secure per session per user. Right? That's the goal there, right? So no one can take your token and try to make calls on another user in some method. But then they do this. So this was to get a transaction history, right, of a member. So you have, what they're looking for is, this is public knowledge, right? Up until here is public knowledge by just looking at the traffic of the application. Account number, which I already said was sequential, so that's even more fantastic. You could brute force this. And the only bits of information it needed was the transaction number, the API access token, and a start and end date. You could go through and enumerate every person's transaction number because they weren't passing the member access token, which is that token that's supposed to be proved that it's you for that session, and tie it back to the account number to make sure that access token was actually supposed to talk to that account number. They weren't doing it. And they also weren't doing it for the set preferences. I could change things on other people's accounts going through, because I could just enumerate account numbers and change the preferences. The preference IDs, I didn't get into too much to know what it was, but it was like email alerts and some contact information. Nothing too dangerous, but still pretty juicy that you could basically mess up a few people's days by doing that. And they were not requesting the member access token still. That report was like copy and paste, implement proper authorization authentication checks on each call. So make sure you use an access token for each call. That was fun. The security group liked it. The PCI lady did not, because she's like, what's all these high findings for? And in the pen test, they did implement all this stuff. So that's always fantastic. Vulns in the wild. Before I got professional in security, I was pulling down apps from SourceForge, GitHub, anywhere I could find web apps, and just running free scanners at it and seeing what would break. And this is only a snippet of the stuff that I found. And cross-site scripting is actually very difficult to fix as opposed to a normal injection flaw like SQL injection, right? SQL injection, you just do parameterized queries, make sure you don't mess up the parameterized query, and you're good. Cross-site scripting, you have to do input validation, output encoding. You know, there's more steps out there. And this was almost every app I looked like. You know, see, we're going back to 2011 is when I was getting the CVEs assigned. And there were public instances of this family connections and web calendar, you know, on the internet. Like I found it wasn't just people running it internally. There were public instances of this stuff that they were trying to fix. Well, I don't think they actually fixed because the people stopped developing this stuff. But that's dangerous, right? So you pull them down open source code. They're like, oh, I want a booking calendar, right? I want people to be able to submit requests to book a room or resource that's out there, and there's issues in it. So code has issues everywhere. Open source, you know, commercially driven software, it's all there. The methodology for going through these sorts of assessments tends to be the same, whether you're doing a web app, mobile app, or a network. This example, we're going to focus on a web app going through. The workflow always follows this 3 steps, right? First is discovery, information gathering. What does it do? What is the app, right? What's its business context? How does it work? And then you want to then, what's it supposed to do and what's it not supposed to do, according to the developers. Identifying inputs. That's where the app is going to break, right? Wherever the user can input something in is most likely where the fun is going to be. Injection issues, authorization issues, authentication issues, they'll all be inputs, right? Username, password, or the token, or the cookie. That's where that happens. And then understand the business logic. You know, is there money involved? Is there a shopping cart? Is it a bank? Can you move money? What things are you not supposed to do when you move money? You know, cross accounts, authorization issues. Those are the fun ones to play with business logic. The first 2 can be automated, right? Running crawler on the website, looking for the inputs, any automated tool can basically do that. It's the assessing the business logic of the application that requires a person, right? We don't have AI to the point yet that can understand whether or not, you know, you can put a negative number in your shopping cart and then retrieve money back from the bank, right? How is the computer going to know that? So that's where the assessments ends up being fun, is poking at the soft spots of the application. You know, what happens if I do this here? What happens if I do this over here? What happens if the parameters are out of order? Does the system care about that? Or is it doing that properly too? When we're doing black box testing, what we're ended up doing is trying to figure out how it works behind the scenes, right? If I was a developer, how would I design this system? If I was looking at this, what could this be doing on the back end? I'm surprised Rafi's not here. He's been a vendor here for a number of years. It sucks because I wanted to chat with him. But Rafael Mudge, the owner of Strategic Cyber, I forget what the company is, wrote Call Ball Strike. Anyone here familiar with Call Ball Strike? Armitage, right? Rafi is a fantastic guy. This quote really speaks to the hacker mindset that we're going through and trying to do. You know, the number 1 trait of a successful hacker is the ability to reason with things one cannot directly observe, right? Black box testing, I cannot observe what your back end is doing most of the time. Sometimes we get access, to the developers and we can see what things look like on the back end, which helps to validate or invalidate different findings, right? But we're poking with something that we can't see what it's doing. We're just hoping it's doing what we want it to do or not want it to do as we're going through the testing. And this quote is, what I share with a lot of folks going through. This is what we have to be able to do as a pen tester, right? You need to be able to reason with that box, that system, the application, to figure out what it should or should not be doing and figure out ways you can break it. Okay, so now we'll get into all the fun stuff for the consumers of security out there. After the assessment, people complain about report writing, but honestly, that is the only piece, the only output of the assessment for a consumer, for the most part, right, is the report. The only tangible piece as a consultant I am going to give to you that you will then share with your developers, share with your system admins, share with your software engineers and system architects, is the report, the findings that we find throughout the assessment. When you're looking for, when we're going through the report, you want to make sure there's proper detail, right? You want a decent description. Most things are pretty easy, and we have some templates internally, for what cross-site scripting is and, weak ciphers. That language is all pretty much standard going through, right? You want to make sure that the affected instances are there. What's the IP address? What's the parameter? On what page is it there? What line of code has the issue? You also want to make sure that the vendor gives you steps to reproduce so that you can then go and verify if the vendor is full of it or not, right? Is this a real issue? And then you also want screenshots, which is proof from the vendor that that issue has actually existed, right? If there's no screenshot in there, what proof do they have? How can they say that's an issue? Remediation. That is a big one. That is a huge one for your developers. And I would encourage you guys who are consumers of security, when you're trying out new vendors, definitely get a sample report from them. Everyone has them. We have sanitized reports for every one of our offerings, right? Companies should have these things so that you can look at what their reports look like. You want to make sure they're finding good things, right? That's always a good thing, right? Well, bad things for you, right? You don't want us to find anything, but that's always a fun call, right? Did you find anything? Oh yeah, we're having a lot of fun. Oh, that means I'm not going to have a lot of fun next week. The inverse relationship of security testing. But the remediation advice is really what's important. I have seen folks put on remediation advice, we'll work with developers to fix the issue. What the hell is that? That's not actionable. That's horrible advice for someone, Especially when we're doing like code level stuff. Like if we find SQL injection and we know you're using Java, you're using JSP, we can give you code examples for what a proper parameterized query looks like. Your vendors should do that if you're getting software security AppSec stuff back in. There should be actionable, real contextual advice for you guys to then take back to your developers and have them fix the issues, right? Very, very important. I'm going to tread kind of lightly here because this could go either way depending upon your stance on this. The report out call is personally my least favorite part of the assessment. I love writing the report because it's kind of like, going back through and documenting what you did, reliving the hack, especially when we get into the red team stuff and I can really brain dump how I stole your users' passwords and how we got into your building. That's a really fun exercise I find to do. But the out call is where, not that it's bad because we'll be challenged by the client. It's bad because some clients have the process where you have to have the report out call and the vendor will get on the call and read through the report. Why? You had the report for like a week. You read it. You shared it internally. All your dev teams are on it. You're on the call. Come with a fluid discussion. I would much rather have a fluid discussion to address your exact points and get the call over with, not because I don't want to be on the phone with you, but because our time is valuable on both ends, right? I'm sucking up an hour of your time, your developer's time, your lead's time, and my lead's time to go through this report. And I've been on report out calls where it was, I read the whole report and they said, okay, thank you, and hung up the phone. Like, what was the point of this? You know, come with questions. And if you have no questions, don't have the call. Like, that's cool too. I've had that some clients as well. They've gone, no, we understand your report. We have no questions. Developers understand what they have to do. And if we run into any issues, we'll come back to you guys. I said, perfect. Great. I can move on. And I've had other calls with clients where I get on. I was like, do you have any questions? Because I really don't want to read to you like you're my 5-year-old kid. I would rather, address your questions that you have on your notepad, because they have notes written and they know what issues they're going to have with it. And I'd rather have that discussion just right up front, get everything out of the way. You read through a whole report, and I've had a client, I read through a whole report and I got to one low finding and they were like, we don't think this is a real finding. Like, you don't care about the highs, the lows where you're going to care about? And he spent 15 minutes arguing with me whether it was a real issue or not. The fix for the issue, by the way, was just to update Apache. So in those 15 minutes, he could have just done apt-get update and solved the issue, but no, he decided to spend our time arguing whether it was a real finding or not for a low, which was just, it was rough. Please don't do that to us. Or do it and challenge us. That's cool. Yeah, this is where the team will question the finding, right? So not just the low findings, but a lot of teams, big companies will have timelines for when issues have to be fixed. Highs certainly have to be fixed very quickly within days or weeks, depending upon the severity of the application and all that jazz. Mediums are at least within a month or so, 60 days, 30-day windows is what the clients end up doing. And lows end up being like the next release cycle, right? So a lot of my arguments I have with clients, and if you are the consumers of security here, and probably that speaks to you in some way, you're going to argue those highs down to a medium every time you can, right? Because you don't want to have to go back and fix all these things that we think is a high. And in some cases, we will lower severities. I've done that plenty of times, where it turns out there was additional controls on the back end that actually would prevent a full-blown issue with this, right? Because when we're looking for issues, we just look to prove that they exist, and in its little vacuum, what its risk rating could be to the application, right? We don't have all the insight into your app and how the back end always works. So they'll go, we actually have like all these things that would prevent that from actually happening. It's like, okay, then we'll lower it down to a different severity level. We've done that. That's understandable. We'll never take a finding out of a report. I've had someone in the middle of a test found a whole bunch of cross-site scripting. Go back the next day, it's not there. Going, what the hell happened? Someone was watching what we were doing, saw that we were finding issues, and then fixed it overnight to try and have a good report. Luckily, we screenshot when we find things, so even though they fixed it, that finding was still in the report. We marked it as closed. Right? And I've had other instances where, high and critical findings are reported to the client as soon as possible so they can get a head start on fixing those things. And then we sent them the report and they were like, wait, we fixed all these things. And I was like, yeah, we still found them. We're not going to say we didn't do any work and your app had no high issues, right? They're going to be in there. We'll mark it as closed and put it in the executive summary so your higher ups know that we closed those things. You close those things, which is good, right? Find it, close it before the test was even over. That's some pretty good turnaround on times, right? But we're not going to take it out. Never take it out. Couple of the points to remember when you're consuming security services is that any assessment is a point-in-time review of your app, network, or system, right? We don't know what it was like before we got there, and we're not going to know what it's going to look like after we got there. And neither will you, as you're looking at it, right? Our issues that we find are found within that time period, and they only demonstrate how bad an application is, right? This is Gary McGraw, our CTO, I don't know if anyone's read his book, Building Security and Building Secure Software. He calls this the badness-ometer, right? When you have a pen test, it's not good or bad, it's we don't know, or oh my God, we need to fix everything. Right? A pen test does not prove good, it only proves bad. And so does secure code review. Most, point-in-time assessments, we will just find the bad things. We will find some good things too. I guess we could say you have proper controls here and there. These sorts of attacks were not possible in the application or system, which is good to know. But you don't truly know how good the application is going through a pen test. Right? All right. Thank you guys for coming out 10 o'clock in the morning to hear me speak. I really appreciate it. I will be around all day. So if you have questions, want to chat, want to tell me I'm wrong, I will be here. Does anyone have any questions now? I guess we got like 10 minutes or so. Yeah. So we've had that. And the classic example of that happening is when we will do like a vulnerable server version. So we know that their version of Apache is like super old, or like we find IIS 5 and we're like, fix that. And then they're like, okay, we fixed it. And we go and look back and all they did was turn off the header. So we can't really tell that it's IS5 anymore or their vulnerable version. And then in code as well, we've had I'm trying to think back. Right, like the one instance, like, so we'll give them a cross-site scripting is also really bad with this too, right? So we'll put it in and say, you have cross-site scripting and here's the payload that we used. So they would go back in and I went to go test to make sure the cross-site scripting was fixed and my first payload wasn't working. I was like, all right, so let me try another one. And the other one worked. Basically, they blacklisted my one, script tag that my alert 100 to make sure it doesn't go through, but not actually fixing the output issues because I could still get, I could tell with the responses back that they weren't output encoding the brackets. It's like, come on, you're not fixing it. Even though we gave you advice, they didn't fix it, but yeah. It happens. As much as we want to, we can't, right? Because for the cross-site scripting example, we can say, no, you're still vulnerable because this other thing worked, and oh, by the way, stop blacklisting our one line and actually fix the code, right? We can do that. But with the software version, if we can't actually prove it's still IIS, we have to close it because we can't prove it's still bad, even though the app looks exactly the same, right? And the IP address is the same, and I doubt they spun up a new server overnight to deploy this, system on to make sure everything worked. But yeah, the header is the classic. They'll turn off the header so we can't actually tell if it's the vulnerable version anymore. Yeah. Yep. Yeah, in the back. That's a loaded question. My opinion is if you're afraid of it breaking in production, your app is really broken and you should just burn it anyway. Right? If you're afraid my scan's gonna knock over your server in production, dude, you got problems, all right? Most of the time we do end up testing in UAT. In a UAT exposed environment or internally in a dev environment. That's where it financially makes more sense to do testing for especially app stuff. Because if we're finding the issues while developers are still writing, there's statistics out there. I didn't include it in the slide, but it is significantly cheaper to fix software issues in development compared to when it's found in production. Right? So, yes. Right, right. The expectation's always there with the client, in the report out call and in our agreements that, if we're tested in prod, we're going to try not to break stuff, but stuff can get broken, right? It's the nature of testing. And if the difference between us and like a known bad guy or an unknown bad guy is they're paying us to do it, right? No one wants to pay someone to take down their banking system, right? But that's unfortunately what happens. And I had it actually happen twice. And the first issue was actually a framework issue with what they were using, and that one was kind of cool. Well, for me, not much for them. And sometimes the fix is just like restarting the box, right? To free up the server. Yeah, there was some weird like crypto issue where if you made the crypto malformed, like the blob malformed, when it was trying to process it in the back end, it ended up going in a loop because it didn't have the proper try catch to make sure it was not breaking it. So it basically sucked up all the RAM on the back end process, and the server had to be rebooted. But yeah, we try to tread lightly. I mean, it happens. And sometimes the client's like, we want you to test in prod because if you can knock this thing over, we're going to rip the developers a new one, right? Yep. And now the flip side to that is too, when you do security testing and something goes down, how much more time do I have? Oh, I still got more time. If anything goes down, the testers get blamed right away, right? Who are my practitioners? Who's been blamed for stuff that you didn't actually do when it goes down? We were doing a network pen test for a client, and they call us up. One of their systems went down overnight, and I wasn't testing. We weren't doing any testing that night. But I woke up to 7 missed calls, 3 voicemails, and 22 emails from the client trying to get a hold of me overnight because one of their systems were down and they couldn't prove whether or not it was me. Which we gave them our IPs. We test from known IPs. They had the IPs we were testing from. One of their systems were down and they couldn't prove. They were trying to get a hold of me to see if it was us or not. And the guy's email was, "I find this unacceptable that we can't get a hold of your tester." It's like, dude, it's 3 o'clock at night. Like I'm asleep. I tell you when I'm testing. And then for the same client, their internal SharePoint, we're doing an external network pen test. So run Nessus, triage, and do some stuff. Their internal SharePoint server went down. And they call us up and they email us and say, "Our SharePoint's down. Is it you?" And we were like, "Okay. Your internal one? Yeah. What's the IP address of that public facing? And then we'll see if it was in our scans that we ran." And they were like, oh, yeah, you're right. There's, yeah. All right. I'll let people go now. I'll be around, like I said, all day. Wonderful. Thanks for all the questions. Yep. Thank you, guys.